In Chapter 7, we're going to take a look at two population parameters. Specifically in Section 7.1, we're going to take a look at population proportions. And the notation that we use for population proportion is P. And then in Section 7.2, we'll take a look at population means. And we use the notation mu for population mean. Oftentimes, these population parameters are unknown, and the reason why we don't know the actual value of P and mu is because in the real world, it's very rare that we are able to survey or collect data from the entire population. So for example, if I wanted to know what is the gender and GPA, or let's just say I want to know what proportion of all BSN students in the United States are male. So let me call that P. Let's say that this is the percent of students who are male. I'd have to survey every single student in the United States and then figure out what proportion of all of these students are male. That would give me P. And then let's say that I want to know mu, which is the average GPA of sophomore year BSN students. In order for me to get the average GPA, I'd have to collect data where I get all the GPAs of every single sophomore year BSN student in the entire United States. So again, I hope that you will agree with me that this is typically unknown because I cannot survey the entire population. So here I've got an example of what that data would look like. And I have ... here because I would not be able to finish this list because I would not be able to survey every single BSN student in the entire United States. But, okay, how would I estimate for P and how would I estimate for mu? And the answer to that is I take a look at a sample from the population. So what we do in statistics is we take a look at a very large random sample from the population. And then from our sample, so let's say that in this example, let's say that our sample is we take a look at the gender and the GPA of BSN students at JU. So let's say we collect data from 50 sophomore year BSN students at JU. That's our sample. And we find out that from our sample proportion, which is P hat, let's say that 13% of them, I'll write this as a decimal, right, are male, okay? And then let's also assume that these 50 students from our sample have a mean GPA, so our sample mean is X bar. Let's say that it's 3.25, okay? So how can I estimate for P and mu if I'm using one sample? And the answer is use your sample statistics. So if I wanted to estimate for P, I would say that my best point estimate, so my point estimate for P would be to use P hat, okay? So our P hat of 0.13 or 13% is a good estimation for P, all right, meaning it is a likely estimation for P. And so we call it a point estimate because it's just one value from one sample. And then if I wanted to estimate for mu for the population and I have just one sample, I could also use my sample statistic X bar. So X bar is also considered a point estimate because it is just one point, right, that we're using to estimate for the population parameter mu. All right, and again, that's just using 1 point from one sample. So we can say that 3.25 is a good estimation for the average GPA of all BSN students if I had just this one sample. So there's nothing wrong with using a point estimate such as P hat or X bar to estimate for P and mu when P and mu are unknown. But there's not any accuracy or precision to using a point estimate. So even though these are likely population parameters, right, it's possible that it is not the correct population parameter or the correct estimation because there's no accuracy or precision. So how do we add accuracy and precision to our estimations? And the answer is we build a confidence interval. So a confidence interval is a range of values. So instead of just using 1 point to estimate for P, I use a range of values. So for example, we will say that a good estimation for P is between some lower limit. So let's pretend that that's 0.11. right, up to some upper limit of 0.15. And so here we have a range of values to estimate for P instead of just 1 point. And the same thing, we could build a confidence interval to estimate for the average GPA as well. And again, I'm making up some numbers here, but we'll take a look at some examples so that you can see where we get these numbers from. So let's say that we come up with an interval that estimates the actual mean or average GPA for all BSN students in their sophomore year to be between 3.01 and 3.75. Okay, so what we end up doing is we end up building what's called 95% confidence intervals, or if you want to be more precise, maybe you want to use a 99% confidence interval. And these confidence intervals, right, estimate for P and mu with more, with some level of accuracy and precision versus using just a point estimate. So we'll take a look at some examples to see how to create these confidence intervals and then how to interpret them.